We got a logarithmic equation, we'll say.
Yes.
And we're going to try to solve it. So you had a great intuition to start. You very quickly saw a scenario like this. Log a, I'm going to say x plus log a of y is actually equal to log a of x times y. So you quickly saw that and you put these two together. So you went log base 2 and the argument x plus 3 times x minus 4 is equal to 3. Okay. Well, you then decided to turn this into or you expanded and simplified, which is a possibility. But at this point, I technically, though it doesn't look like it because it's such a large looking equation, I'm going to simplify this. If I said let, I already used the letter A over here, so I'll do something different. We'll say Z, okay? Not Z or Z. I don't remember how we say it here. Is it Z or Z? Do you remember? I don't know either. Z equal x plus 3, x minus 4. And when we do that, it's not something we have to do, but hopefully it gets us to the visual effect that we want. Is log base 2z is equal to 3. Well, I can change this into an exponential function. This is my base, this is my power, and that's technically my answer. So I now have 2 to the power of 3 is equal to z. All I have to do is substitute back in this piece. Yeah. So when we go to do that, 2 to the third is equal to x plus 3, x minus 4. So your intuition is really good. We do want to distribute. And the reason we want to do that is because this is going to be some quadratic. And in order to solve for quadratics, we have to set it equal to 0. So we have to move this piece over. So we end up with 0 is equal to x plus 3, x minus 4. I should have distributed. Minus 2 cubed. At this point, I've moved everything. Now we're just essentially working with our quadratic. What we get? X squared plus, no, not plus. I think it's minus x. Minus 12 minus 248. So we get x squared minus x minus 20. I'm going to say x minus 5, x plus 4. And we end up with x is equal to 5 and negative 4 as potential answers. We can plug back in to double check. 3. We can plug back in, which we'll want to do here. We have our two answers, 5 and negative 4. I'm going to bring the original answer over just so we can see it a little better. But if we say it was log 2 x minus 4 plus log 2 x plus 3, I think it was. And we just want to remember that our answers were x minus 5, no, sorry, positive 5, and negative 4. Okay, let's say we took this negative 4 and plugged it in. Okay, if we do negative 4 here, we end up with log 2 of a 0. So our question is, whatever our potential answer is here, is this a possibility? Can I take base 2 to some exponent and equal 0? Is this possible? Yeah, all right, this is possible. What about in this scenario here? We're going to say log 2. If I put in negative 4, I end up with negative 1 is equal to 3. Sorry, not equal to 3, equal to something, because technically there's more to this. Can I get 2 to the power of something is equal to negative 1? Can I get my exponent to have a negative value? So this could be a tricky one to think of. So what I'm going to do is I'm going to draw a regular exponential equation that has no transformations to it. And they usually look like, that's a straight line. I want it to be curved. They usually look like this. So my question here is this round possible? Can we get negative values with our exponential functions? If we transform them.
Oh, sorry.
Yeah, but if it's not transformed, we can't.
No.
So in that scenario, what we're going to say is technically our negative 4 is not a possible answer to this one when we go back to test. 5 will work out fine because this will be positive and this will be positive. But if we have a negative argument, we technically can't have that as an answer. Okay? You were right on, in my opinion. You were off by, I guess, a little spot.